let's have a summary of the thermodynamic potentials. So by definition, thermodynamic potentials are state functions that when used along with the corresponding equation of state describes the equilibrium behavior of a system as a function of their natural variables. We have discussed the natural variables like for u, we have seen the natural variables are v and s, vs. For h, the natural variables are p and s. For a, the natural variables are v and t. For g, the natural variables are p and t. See that you memorize this one. Now, what are actually meant by natural variables? So, natural variables are a set of appropriate variables, which are suitable variables that allow to compute other state functions like pressure, volume, temperature, entropy, etc. So if p and v are the natural variables of a function, then other state variables means t and s should be calculated, and if v and t are the natural variables, the remaining two should be calculated. So other state functions by partial differentiation of the thermodynamic potentials. Okay, so such type of variables are what is known as what? Natural variables. So for example, you know that just you have u. So u is a function of v and s, right? So v and s are the natural variables. So what are the other two remaining state functions? Other remaining state functions are p and t, right? P and t. Now you can see that we have already derived. We have seen in terms of u, you can write p is equal to minus dou u by dou v, minus dou u by dou v at constant s. Similarly, t was also defined in terms of u. That was t equal to dou u by dou s, dou u by dou s at constant v. That is what is meant by what is given here. So natural variables are a set of appropriate variables, suitable variables that allow to compute other state functions. Other state functions. Here it is p and t are the other state functions other than v and s, right? By partial differentiation of the corresponding thermodynamic function. So you are taking partial derivative of u here. So that is the meaning of this one. Okay. The thing is that you have to memorize for the time being which are the natural variables. Okay, it's not a difficult task as you know. So I will just suggest you a memory technique. Okay, you can make your own techniques. This is one way in which I used to remember. Everyone will have their own methods. So like what are the things? First of all, you remember the order. Okay, that is by multiple repetition you would be able to remember the order. I think by the time you are able to recall, okay, which are the thermodynamic potentials of our interest. U, H, A and G are the thermodynamic potentials. Okay, U, H, A and G. Now what are the remaining variables of our interest? Other variables which comes as the natural variables, they are pressure, volume, temperature and entropy. So altogether 8 variables we are using in all potential related topics. So U, H, A and G, and other is P, V, T and S. So the common speciality is that this all 8 of the variables are state functions. So these are the common properties. All these 8 variables are state functions. Okay, but out of these 8 functions, these 4 belongs to a class which we call two of them or a pair of them will be known as the natural variables. A pair of them will be the natural variables. Okay, now these four they form a group. They all are called thermodynamic potentials because they have the properties of potential function. And the main property of a potential function is that they have the dimensions of energy. And these are the conceptual points that you have to keep in mind. So only those which represent some kind of energy or which are having the dimensions of energy will be named as what? Potentials. That is one reason why we don't call pressure, volume, temperature and entropy as potentials, thermodynamic potentials. Instead, only U, H, A and G are known as potentials because they should have the dimension of energy, or they should behave exactly like a potential function, especially like potential energy in mechanics or in electrostatics, right? Now, that is the thing. So all the 8 are state functions, and 4 of them are behaving similarly, and the other 4 are remaining similarly. So these 4 behave like the natural variables or basis functions. Basis functions, when you use legendary transformation, they are known as basis functions, and these 4 are the state functions with dimensions of energy known as the potentials, right? So you understood all the 8 of them. Now see what are the natural variables of V and S. You can have the permutations, separate permutations of the thing. So one thing you note that here it is Vs, second one it is Ps, then there is Vt, Pt. So this is a Vs, Ps, Vt, Pt. Vs, Ps, there is some rhyming, right? Vs, Ps, Vt, Pt. Memorize it some way. Okay, if your memory skills are good, then you need not have much worries. But if you are not so good at recalling equations and quantities, be careful. You will also be able to do. Okay, so Vs, Ps, then Vt, Pt, and see U. Already you have remembered U, H, A, G. That order you remember. U, H, A, G. Then U is Vs, H is Ps, A is Vt, G is what? Pt. Okay, so it's just like V, then P, starting one I am writing, then again V, then again what? P, right? Then here S, here S, here T, here T. Okay, Vs, Ps, Vt, Pt. That is one thing, one order. Vs, you can even remember, okay, UV, ultraviolet. Okay, so after U, V will come. You can remember like that, UV. Okay, something, or V, whenever it is V, it can be what? Either Vs or Vt, right? So it's UVS, Vs, okay, Vs something, or Vs, Vs stands for our Vs Achyutanandan, okay, or anything of that, say like, then it is Ps, when it is V, it is next one is P, Ps, you can see, HP, right, HP, something of that kind. HP is like it's a HP company, right? Okay, your laptops like that, HP. Then AVT, it's quite easy to remember. This is one thing that I do not forget because this is one of the brand of tea that I like. Okay, AVT. So it's quite simple, I think. If one or two you remember, you fix it, then the other thing can be automatically the remaining one. Just some elimination technique in your objective type examinations. AVT. And GPT. GPT is also very easy to remember. I told you in which situation Gibbs free energy is relevant, in studying the equilibrium properties of chemical reactions, right? Phase changes and all. And I told you that usually whenever you write a chemical equation or chemical reaction like A plus B gives rise to C plus D, you usually write above the arrow showing the direction of reaction, like some 273 Kelvin, 180 atm pressure, etc. So what is this one? This is temperature and pressure and temperature. So pressure and temperature involvement comes in chemical reactions where G is important. So you can remember the natural variables of G will be pressure and temperature. Okay, so AVT you can remember, GPT you can remember, HPS you can remember, and UVS also you can remember. See that you just don't go on listening to the lecture. See, you write it and try to reproduce it. Usually if it was a face-to-face class, I would have made you to write it and memorize it in the class itself, but so I hope that you will be doing it yourself. What I can do in this context is just to mention you some mnemonics. It's not so difficult. Okay, that's what I want to tell you. Don't be scared of recalling all the equations, because these equations are so relevant. And if you master this particular topic, I can assure you one thing, that just scoring in any examination, okay, conceptually you will be having an edge over others. That's one thing, because just knowing something is not enough to be successful in our system of education. Okay, knowing the concept and recalling and using the concept at the right time within the limited time is also important. Okay, so that's why I urge you to just memorize these equations along with a good conceptual background, right? That will be a added advantage for you anywhere, okay, wherever you are using these concepts. Okay, so they have dimensions of energy I have already mentioned. Now one thing that is clear from our discussion so far is that out of the 4 thermodynamic potentials, you get rid of this U and H, and the remaining 2, A and G, Helmholtz free energy and Gibbs free energy, you know, these 2 functions, they are named as free energies. So these 2 are named as free energies. The reason I told you, okay, the reason you can remember, just remember it's a basic equation. So what is the basic equation? So A is equal to, you know, A was obtained from the the Legendre transformation of U. So U minus Ts. A is equal to U minus Ts. That was your equation. And also you got G is also equal to what? Instead of U, it will be H. So the first 2 things will be coming, okay, here. Or last 2 potentials will be obtained from the first 2 potential by the method of what? Legendre transformation. That is the way in which also you can remember. So here also it is what? H minus Ts. Can't you see that Ts amount of energy? Okay. Certainly we have seen that Ts will be having the dimensions of energy, because A and U are having dimensions of energy, G and H are having dimensions of energy. So you can see Ts is getting reduced, right? And you know, as S is a measure of unavailability of energy, Ts will represent the unavailable energy, even for a reversible engine. Okay. So what is remaining after subtracting the unavailable energy will be some sort of what? Available energy. So both A and G are available energy which can be converted into useful work. So that available, instead of the word available, we are using, they are free. Is it not? Like, you know, you are asking, you know, are you free now? It means that are you available for some service now? That's why it's known as free energies. The word free comes from available energy. Available for what? Available for doing useful work. It means that so usually this A and G are also known by another term in engineering science. They are also known as exergy, and that's quite a interesting term. Exergy, because you know that was obtained from it is rhyming with entropy and energy. That's why it's named as exergy. Okay, so what is exergy? Exergy is actually the available energy. So this is a European term that is used for free energy, exergy. And the US scientists, they prefer to use available energy. That's all. Okay, so remember that it's because that is the actual energy that is available. Okay, means even the ideal Carnot engine will not be able to convert complete internal energy into useful work. You know, there is an efficiency, maximum efficiency even for a Carnot engine or a reversible engine. Okay, and that term is represented by Ts, which is known as the latent energy. That is what we are seeing. That is the lost energy, right? Fine. So it's quite easy to remember this one, I think. So A and G are known as the free energies. Now, choice of the proper potential, that is why I told you, and we have seen that U, H, A and G, all these are the potential functions, and which potential function has to be used for describing the properties of a particular system. It depends on the nature of the process undergone by the system, whether the system is undergoing a process under under isochoric and isentropic conditions, isobaric and isentropic conditions, or isochoric and isothermal conditions, isobaric and isothermal conditions. Several combinations are possible, right? So depending on what kind of a process is undergone by the system, you will have to choose proper thermodynamic potential. That is your skill. Okay, for that you have to identify what are the natural variables of each of them. Okay, so now if these functions are expressed in terms of their natural variables, all the thermodynamic properties of the system can be calculated by differentiation alone, and that is the mathematical advantage of defining potential functions. if each of these potential functions are expressed in terms of their natural variables, means you are writing u in terms of v and s, h in terms of p and s, and so on, then all the thermodynamic information regarding a system can be just obtained from this function by simply doing differentiations. And that's what you are seeing here, is it not? You are writing u v of s, then can't you obtain the pressure of the system? Yeah, just take the differentiation. Can't you obtain the temperature of the system? Yeah, you take what? The differentiation, because other variables are already known to you, right? So that is the meaning of that. It becomes quite simple. Just a matter of differentiation will take you to other variables also, right? Now also as defined in the definition of thermodynamic potentials, you remember that they are especially useful. These thermodynamic potentials are so important because they always help us to understand the equilibrium behavior of systems. Means system which have already reached what? Thermodynamic equilibrium. And you know what we are discussing now is what we are interested, or what is easy to deal with, is what equilibrium thermodynamics and equilibrium statistical mechanics. Because once the system has reached some sort of an equilibrium, the variables will be having a fixed value, which can be easily measured by using measuring devices and all, right? So that is a short summary of thermodynamic potentials here. Now just let me tell you something more also that will be helping you. Like do you remember u? Okay, see, this is u. This much is clear to you, I think, by the time you are able to recall it. U will be always recalled as a function of Vs, right? So then what is the other one? Just try to recall it along with me, right? H equal to h of, what do you write? After V there is P. V will be replaced with P, volume and pressure, okay, Ps. Then the next one is A of, what is that? Then after Vp, then again Vp, that is the order. V, then what? T, AVT, is not? That's what I told you. HP, UV, right? Then final one is G. G is a function of, what is that after V? GPT, right? G, remember, pressure and temperature. So this much you can anyway do, right? Hope that this much is okay with you. Then from this you can go to the value of change in thermodynamical potentials. So for infinitesimal process you will be writing du. What be du equal to? How do you write du? You know how to write du. Du is equal to, mathematically, can't you write, so we have seen that how to write this particular thing, like f of xy, what is the df equal to, you know how to do. So that will be, mathematically it is dou u with respect to dou v, dou u with respect to dou v, keeping the other one constant, which is the other one, s is constant, into what? dv into dv plus dou u. We have done it several times in our previous modules. Dou u with respect to the chain rule in partial derivatives or differentiation. Dou u by dou s, okay, at a constant what? At constant v times ds. That is the thing. Similarly, this equation, how do you write it? dh, differential change in h, will be equal to dou h with respect to the first variable p, dou p, keeping the other variable as constant, that is s, times what? dp times dp, then plus dou h with respect to dou s, keeping the other variable p as constant, times what? ds. That is there, right? Now the third one is dA equal to dou A with respect to dou V, keeping temperature constant, times what? dV plus dou A with respect to dou T, keeping V constant, times dt. Now last one, dg can be written as, dg is equal to dou G with respect to dou P, keeping T constant, times dP plus dou G with respect to dot t, keeping p constant times what? dt. So these are the differentials by simply following the mathematical technique. Now this equation, this equation is equivalent to, that's what you have to remember, this equation is equivalent to minus p dv, this already we have seen, minus p dv plus t ds. This equation is equivalent to v dp plus t ds. Okay, this equation is equal to, not equivalent to, equal to minus p dv minus s dt. This is equal to v dp minus s dt. Just, and these all equations, du equal to what I have written, du equal to this one, dh equal to this one, dA equal to this one, and dg equal to this one, already we have written and identified. Okay, another way also, right? So these equations are basically known as the Gibbs relations in thermodynamics. du equal to this one, dh equal to this one, okay, dA equal to this one, and dg equal to this one. You can forget about this particular set what I have written here. These things you can forget about actually. Now you can directly remember this one if you can. So then these are known as what? The Gibbs equations in thermodynamics. Not so common, okay, but they are named so, right? Now how do you recall? How do you recall this one? See, for that you can just you can directly recall this one. For that what you need to do only is that you remember the natural variable. See, this u equal to, there will be v is here, so dv is here, s is here, so ds is here. We did the reverse in our derivations. Now I am telling you to do the other way. Okay, now here natural variables are p and s. So p is there, so there will be dp. S is there, there is ds. The next one v and t. So dv is there, dt is there. P and t, dp is there, dt is there, right? So from the natural variables you can write first. So for example, you have got u. So then recall u is that of vs. Then automatically you can write, therefore du will be equal to, two things are sure, there will be a term containing dv and there will be a term containing ds. Now what you do is that you have to find out its proper coefficient. To find out the coefficient, let me tell you one thing. Just look at these expressions, four expressions what I have written here. What you can find, if it is v, who will be along with that? P will be there. PV, they always form a pair. P and V will be always forming a pair in all these equations, Gibbs equation. And when there is T, there will be S. So T and S will be always paired. This is why I told you to just stare at the equations. Okay, so you can find out a lot of common threads. There are some secrets. Okay, so T and S will be always paired. Either it will be P into dV or V into dP. That depends. T into ds or S into dt when it appears in Gibbs equations. Okay, so these will be paired and these will be paired. Why they should be paired? Why can't there be a pairing of SP and TV? Why can't be a pairing? The reason is well and clear. Because of the reason that U should be always having the dimension of energy, right? If U is having the dimension of energy, then each of these terms should be having dimension of energy. That is something very, very important. All the terms here should be having the dimension of energy. And you know, pressure into volume is nothing but work done. That is why we have been writing minus PdV. Minus PdV is nothing but equal to d bar W. Don't remember. So P into V, pressure into volume, is having dimension of work. Work is dimension same as that of energy. And also we have seen that TS is having dimensions of what? Energy finally. Okay, so T is joule per Kelvin and T is Kelvin and S is joule per Kelvin. It gives you joules. So that is why we have been subtracting TS amount of unavailable energy, right? So whenever it is paired, it will be PV paired or TS paired. That should be so. Then only it will be dimensionally correct. So hope it is easy. Now two more observation. Whenever it is PdV, there will be a minus sign. Don't you see that? PdV appeared here and PdV appeared here. Okay, so in PdV here, can you see this written as minus PdV? Yeah. When it is VdP, it will be plus always. VdP is plus here, VdP is also plus here. It's not minus. So that also can be seen. Similarly, whenever it is SDT, it will be minus. So minus SDT, minus SDT. Can't you see that? SDT is minus, but TDS will be plus. TDS will be plus. Is not quite see? Can't you see there is a lot of symmetry involved in all these equations? And identify the symmetry. This symmetry will help you finally to recall the equation very easily. Okay, and I once again request you that just soon after this particular session, if you find time, take a piece of paper and try to recall and write all these equations systematically. Okay, all the equations should be reproduced regarding thermodynamic potentials. All equations that I have discussed should be reproduced within half an hour, within some 10 minutes you can do it. Okay, but see, what I suggest you is that try to do it as early as possible before you lose your memory, right? And because I need it, you need it, or we need it, okay, for our further discussion, not only in your UG classes, to take it forward. Because once it is solid and you are confident that you are able to reproduce it, you will be benefited, see, well in the days to come. That I'm sure about, right? That is something, okay, quite easy. Now even see, let me just conclude it by telling this one. See, just what is this dou u by dou v s? Dou u by dou v at s, that is minus p. Just compare the coefficient of dv here, compare the coefficient of dv here and dv here. So you will be able to write from that p is equal to, many ways you can write it, okay. P is equal to minus dou u by dou v. You can check it back. Minus dou u by dou v at s. We have already written this one. Okay. And similarly, you compare the coefficient of ds here in both these equations. ds here and ds here. So what is that? That is t, plus t only. So t is equal to dou u by dou s at v. Right. Similarly, you can write 6 more relationships from comparing the coefficient of dp and dp, ds and ds, dv and dv, dt and dt on both sides of the equation. You will be able to write altogether 8 equations, and these 8 equations can be called as derivatives of the thermodynamic potentials. So derivatives of the thermodynamic potential will always give you the missing parameter, okay, out of the 4 variables p, v, t and s. Okay. Now one more thing, suppose this usually happens in your competitive examinations. You will be given a number of relationships like this. Now you remember it all systematically, and later maybe after 1 year you are writing an examination where you are given a question like this: which of the following relations are correct, or which of the following relation is correct, or which of the following relation is wrong, right? When you look at the equation, you will feel that all these equations are looking very similar. Okay. So the thing is that you have to remember all these equations with its proper sign and all. So at that time you should be able to make it, because there is every chance that you will forget. All these equations may be forgotten, but the technique, if you learn how to memorize it, if you revise it just before 1 or 2 days or 1 or 2 weeks, you will be able to reproduce it with confidence. Okay, and that's why I'm just mentioning all these common properties. And one thing more, it will be helping you. So did you see that this one? See, did you see that we are writing p equal to minus? The signs you will have to obtain from suitable techniques and all. Okay, signs, because the sign is a matter of memorizing. Now there are relations, like for example I told you, you will get from this equation you will get one thing. See, what is that? Sorry, this one, yeah, dou a by dou t. When I say dou a by dou t at constant v, it's equal to minus s, right? This equation, there is no doubt, whenever it is an equation for s and on the other side it is a free energy, there will be a negative sign. The reason I told you, because as s increases towards equilibrium, the free energy should reduce to the minimum for equilibrium. So whenever it is equation for s in terms of the free energy, there should be a minus sign. So s will be equal to minus of, you can write. Similarly, another equation that you can write is from this one, dt, right? S is equal to, it will be minus of dou g by dou t at p. Dou g by dou t at p. So that is also something that you can clearly recall. So these negative signs you can remember. Otherwise, you always remember, see, just in this equation, did you see that? You cross multiply it. Here it is V. Neglect this D and all. Here it is V here. When you cross multiply, what will come? PV. PV equal to U. And why? Because PV is not, when you cross multiply, you will get X equal to Y like that, is not? So dimensionally X and Y should be same. And it is U here, energy. So automatically the product, okay, is not, when you, this X should have the dimension of energy. So I told you already that whenever it is P should be always paired with V only. P will be always pairing with V. Similarly, you can check with any equation. See, you can see that. Now you try to cross multiply this equation. See, here it is S, right? So S into T, it's just like TS. And we have seen that TS also will be having the dimension of energy. This is correct. So just check with every equation that you do, you will see that cross multiplying, the dimensionality will be correct. Okay. So if you are given that T is equal to something like that, if you are given an equation in an examination, this is usually what is given. Okay, T equal to dou U by dou V. T equal to dou U by dou V at P. Will it be correct? Okay. So you may think that there may be some equation like this which you do not remember. See that there cannot be an equation like this. That is a fact. This equation cannot be true. Even though you do not know what is the correct relation, you can strongly say that this equation cannot be true. How do you say that? How do you ascertain that this equation cannot be correct? The thing is that just cross multiply. These are the basic skills that every physics student can master. See, just cross multiply and see. What is that? It comes TV, T into V, volume into temperature. Volume into temperature, you are telling that dimensionally, the dimension of volume into temperature is same as that of dimension of energy. Can it be true? Volume into temperature, the dimension is never equal to what? That of energy. So you know this is wrong. So this one is exactly wrong. And this is one thing that will be helpful for you in your competitive examinations. Okay, that is why people, okay, those who are able to use the concepts. Okay, yeah, maybe some of you at least would have undergone some okay, coaching for your entrance examinations in medical engineering entrance examination, maybe soon after your +2 classes. There you remember that what makes, okay, a difference is that your concepts can in many a times help you to rule out the options. Rule out the options. Okay, even though you do not recall which is the correct answer, if you are given 4 or 5 answers with proper concepts for which you need not have much memory, okay, you will be able to rule out what are wrong, even though you do not know what is correct. So finally, you will be reaching automatically near to the correct question. No, sorry, correct choice. That is also a way of what doing things. So hope that this discussion was useful for you. Be patient enough and repeat what I have told you, that soon after this one, without getting late, try to reproduce all the 4 thermodynamic potential functions and its related equations. Master it now itself, so that finally, okay, wherever you have to reproduce it, you will be confident enough. And I have already just tried to summarize all these relationships into a table, a pretty table. Okay, so whatever we have discussed in some 2 or 3 hours, I know that I have just stretched it too much, but it's done purposefully. Okay, it's done purposefully because I understand what is the relevance of all these things, and that all the 29 of you should be able to recall all these equations. That's my aim. Okay, all the 29, okay, should be able to master these equations. That is the barest minimum that a physics student should have after okay, studying thermodynamics. So just I have posted this particular table for your easy recalling in your additional reading material, which you can access in your Google Class. Just either you copy it or you verify it, or you take a printout of this one, keep it with you. It will be one of the concise, precise form of summary of all the thermodynamic potentials equations that we have discussed in the last 5 or 6 sessions. Right? Hope that it will benefit you. Thank you.